Hello everyone, I welcome you all in the logical learning platform. In this lecture, we will learn graphical solution of linear programming problem with the help of one example. So let us see the example. Here we have to maximize z, this equal to 2x1 plus 3x2, and the constraints are x1 plus x2 less than equal to 5, x1 plus 2x2 less than equal to 6. So in graphical method, what we do? We start with converting these inequalities into equations. So first equation we can write x1 plus x2 equal to 5. Now we'll try to plot this equation in a two-dimensional plane. For example, suppose this is the two-dimensional place. Here you can write x1 and here you can write x2. So we'll try to plot this line here in this two-dimensional plane. So how can we plot? For this we need at least 2 points from where this line is passing. So the simple way, one way is you can assume you can assign different values to x1 and you will get different values to x2. For example, if you say x1 equal to 1, then you will get x2 equal to 4. If you say x1 equal to 2, then you will get x2 equal to 3 and so on. Another way to find the 2 points, we try to check the point where it is passing through x1 axis. Suppose for example this is the point where this line is passing through x1 axis. So if this is the point, it means at this point x2 will be 0. So simply put x2 equal to 0 in this line, then you will get x1 equal to 5. So it means the coordinates of this point are 5, 0, x1 equal to 5 and 0. So coordinates of this point will be 5, 0. Similarly, if we wish to find the point where it is passing through x2 axis, then we will put x1 equal to 0 and x2 equal to will get 5. So the coordinates of this point will be 0, 5. So x1 equal to 0, x2 equal to 5. Now we can join these 2 points and we will get the line. Similarly, for this line, convert the second equation x1 plus 2 x2 equal to 6. We have converted this inequality into equation. Now we will find the points where this line is passing through. So first, in the same way, put x1 equal to 0. x1 equal to 0 means the point where this line is passing through x2 axis. So you will get x2 equal to 3. Second time, if you put x2 equal to 0, x2 equal to 0 means a point where this line passing through x1 axis. So you will get x1 equal to x2 equal to 0 means 6. So one point is 0, 3. This is x1 0, x2 0. Here this is x1 equal to 6, x2 equal to 0. So 6, 0. So 0, 3, this point will be somewhere here, and 6, 0, 6, 0 somewhere here. So this line will pass through these 2 points. So in this way, we can plot these 2 lines. So here we have the points 0, there is 5, 0 and 0, 5 for this line, and for this line 0, 3 and 6, 0. Now we can summarize all these things here. So here this is the problem. I have written here the line x1 plus x2 5 is passing through the point 0, 5 and 5, 0. Say this point is A and this point is B. So 0, 5 means 1, 2, 3, 4, 5. So you can use a graph paper, or if you are using a plain paper, then you have to use proper scale, so that you can draw all these lines properly. So this is the point 0, 5. Say this point is 0, 5. This point is A. Next point B, 5, 0. 1, 2, 3, 4, 5. So this point is say B, 5, 0. So now look at this. We have to draw the line, and we can draw a line in this way. This line is passing through these 2 points, and here you can write the equation of this line. This is x1 plus x2 equal to 5. Now next line is 0, 3 and 6, 0. So 0, 3, this point is 0, 3. Say this point is C. C, this is 0, 3 and 6, 0. 6, 0, this is the point. Say this is D, 6, 0. So now join these 2 points, then you will get the next line, and this line is, say this line is x1 plus 2x2, 2x2 equal to 6. So now we have drawn these two lines. Look at this. We are dealing with inequalities, not lines. It means we have to find all the points which satisfy this inequality, that is x1 plus x2 less than equal to 5. So every line, if you draw a line in this space, then this line will divide the space into two parts. For example, if you look at this line x1 plus x2 equal to 5. So one part is in this side and one part is in this side. So now we have to decide which part is the basically solution space of this inequality. So for this, to get the information about the solution space of this inequality, simply you can choose any point either from this side or from this side. So the simplest point is this point 0 0, because this coordinates of this point are 0 0. So if we put here x1 equal to 0, x2 equal to 0 in this, you will get 0 plus 0 less than equal to 5. So 0 less than equal to 5, and this is true. So if it is true, it means this side, the region in this side, you can put mark arrow in this way to show that this region is the solution space of x1 plus x2 less than equal to 5. Similarly, to check the solution space of this line, this inequality x1 plus 2x2 less than equal to 6, again simply use this point 0 0. So 0 plus 0, 0 plus 0 less than equal to 6, and 0 less than equal to 6, this is again true. It means for this line also the region is towards 0 0. So now we can show these regions through these lines. Now we have to find the feasible region which is a common of all these constraints. Now look at this, x1 is greater than equal to 0 means we need a region above this, and x2 greater than equal to 0 means we need region in the right hand side of this line, and below this line, below this line. So the common region will be this part. So we can find the common region. You can shade it, or you can draw some lines to denote this region. So this is the region. So this is the common region, and look at this, these are the boundary points, this one, this one, this one. Now we have to find the point where z is maximum. So it can be possible only at corner points. So no need to check at this point is basically 0 0. You can say at this point z will be 0. So we can check the value of z at this point, this point, and this point. Say this point is E. Now we have to find the coordinates of E. So how can we find the coordinates of E? Look at this. This point E is the point of intersection of these two lines, x1 plus x2 equal to 5, x1 plus x2 equal to 5, and x1 plus 2x2 equal to 6. So subtract this one. So here this will cancel out. You will get minus x2 equal to minus 1. So x2 equal to 1. So x2 equal to 1. Now x2 equal to 1. So x1 plus x2 equal to 5. x1 plus x2 equal to 5. x1 plus x2 equal to 5. And x2 equal to minus 1. x2 equal to minus, sorry, not minus 1, x2 equal to 1. So x1 plus 1, this equal to 5, x1 equal to 4. So look at this. In this way you can find the point of intersection of these two lines. To find the point of intersection, you can simply solve these two lines. So here we will get x2 equal to 1 and x1 equal to 4. So it means the coordinates of E are 4, 1. If you are using a graph, you can easily visualize this. Look at this point. This is 1 2 3 4, and this is 1. In x1 this distance is 4, in x2 axis this distance is 1. So these are the coordinates of point A. Now we have three corner points, C, E and D, C, E and B. So each of the corner point we find z. So start with point C. Coordinates are 0, 3, z, 2x1 plus 3x2. So 2x1 plus 3x2 is 0 plus 3 into 3 9. So this is 9. Now at point E, the coordinates of E are 4 comma 1. So 4, this is 4 8 plus 3, this is 11. 8 plus 3 11. Now at point B coordinates of B are 5 comma 0. So this is 10 only. So these are the values of Z at different points C, E, B. This region, you can also write this region as feasible region. Feasible means possible. So basically this region is the solution space for all these constraints. Means in this region all the points satisfy these constraints. And now we have checked the corner points, because at the corner points we can get the maximum value of Z. So at 3 points C, E and B we have calculated the value of Z, and look at this, at point E we are getting the maximum value of Z. That's why the solution of this problem is x1 equal to 4 and x2 equal to 1 and maximum z this equal to 11. So this is the answer of this problem using graphical method.